Thanks to Brilliant for supporting this episode of SciShow. Go to brilliant.org/scishow to learn more. We know that you guys are a curious bunch, and we wouldn't have it any other way. And we know that you have all kinds of questions about how the world works. A few years back, Google asked us to tackle some of the questions that people ask most often, and hopefully come up with some answers for the inquiring minds that want to know. So here are some of the world's most asked questions and their answers. Apparently, a lot of people wanted to know how to get rid of the hiccups, and it's not that surprising. They're pretty annoying. Hiccups happen when our breathing system gets a little bit confused. To get rid of them, we have to find a way to get it back on task. Here's Hank with more.
Today's question is, how can I get rid of hiccups? People have all kinds of hiccup remedies that they swear by, none of which seem to have much to do with each other, like swallowing a teaspoon of sugar or guzzling a glass of water or just holding your breath. But to figure out how to get rid of hiccups and why we get them in the first place, you gotta start with getting to know your diaphragm. The diaphragm is a sheet of muscle under your lungs that is one of the most important muscles you have if you enjoy things like breathing, and a hiccup is just an involuntary spasm of the diaphragm that causes it to contract suddenly. When that happens, you take in a gulp of air really quickly until your vocal folds, the membranes at the top of your throat, clamp shut. That's what causes the hic sound. Most of the time, the spasm stops as quickly as it started, and you can just say, "Excuse me," and get on with your life. But sometimes those spasms won't stop, which means it's time to get your diaphragm to relax. To do this, you basically gotta hit the reset button on your nervous system, or at least the part that controls your diaphragm. You can do that in a couple of different ways. One is to stimulate your vagus nerve. That's a nerve that runs down your neck from the base of your brain, and it regulates some of your body's most important functions, including your heartbeat and your breathing. Basically, you need to stimulate this nerve, distract it if you will, so it'll stop constantly zapping your diaphragm. So some people have luck getting rid of hiccups by swallowing a teaspoon of sugar. Sounds delicious, but it's actually harder than it sounds. The act of gulping down those dry granules can provide just enough confusing stimulus for your vagus nerve to start focusing on your throat and leave your diaphragm alone. Another, more common approach to kicking the hiccups is to increase the level of carbon dioxide in your bloodstream. That might seem a little weird, but your natural breathing rhythms are regulated by your CO2 levels, and if they get too high, your nervous system will signal your diaphragm and lungs to make sure they're doing their job. And this is what's behind most of the hiccup busting techniques you've probably heard of, like holding your breath or breathing into a paper bag or drinking a tall glass of water. All that stuff stops your intake of oxygen and ramps up your internal CO2 concentration, which signals your diaphragm to get its head in the game and fix things. If the human body weren't so weird, it wouldn't be so fascinating.
Fascinating, weird, and sometimes our bodies can be pretty high maintenance. For some of us, it takes work just to get to sleep. So it's no wonder that people take to the internet for answers. Falling asleep should just happen, right? Well, it depends on everything from your bedtime to your phone habits. But there are a few things you can do to help ensure you get regular shut-eye. This time, Michael's here to share the details.
The first thing you should know if you're having a hard time getting some shut-eye is that you're wired to sleep regular hours, going to bed the same time each night and waking up the same time each morning. Having a regular wake-up time seems to correlate pretty highly with the ability to fall asleep consistently. This is because it keeps you aligned with what's known as your circadian rhythm, your body's natural tendency to stay in sync with the cycles of day and night. And you know what controls your body's circadian rhythm more than anything else? Light. A lot of the help you get falling asleep comes from hormones. They lower your heart rate and reduce your blood pressure and basically let you relax. The key player here is the hormone melatonin, and it's regulated by your exposure to light. In darkness, it flows freely. But when you're exposed to light, whether natural or artificial, the release of melatonin stops. So you know what that means? No phones or laptops in bed. The light emitted by electronics confuses your body into not knowing that it's time to sleep. So scientists suggest at least an hour of screen-free time before bed, though I am completely incapable of that myself. Another obvious enemy of sleep, caffeine. Even though you might think that cup of coffee after dinner might only affect you for an hour or so, studies have shown that caffeine consumption as much as 12 hours before bedtime is linked with insomnia. And even the way you think about sleep can affect your sleep patterns. Worrying about not getting enough sleep is a common enough cause of insomnia that it has its own name, sleep onset insomnia. But you know what's really weird? A lot of the time when we feel like we can't sleep, We actually are sleeping. When scientists rouse patients in the first or second stages of sleep, more than 60% of them say that they weren't sleeping, even though they were. Now, of course, there's a whole class of medications that will help you sleep, from antihistamines to pharmaceuticals known as hypnotics, which include Ambien and Lunesta. But research has shown that while patients can fall asleep faster on hypnotics, the effect is small, adding only about 15 minutes to their sleep times. Other studies indicate that our minds are significantly more powerful than any medications. In double-blind studies, patients who were simply told that they were taking a sleep drug ended up sleeping far better than patients who were told they weren't. So if you want to know how to sleep, the answer is right there in your head.
But it wasn't just sleep that the good people of the internet worried about. We all want to know whether we're taking good enough care of ourselves in general. Like, am I drinking enough water? At some point, someone has definitely told you that you should drink 8 glasses of water a day. But is that true? The answer to that question is probably much more straightforward than you would think.
Today's question is apparently on a lot of people's minds. How much water should I drink in a day? Well, it's helpful to keep in mind that you basically are water. It's your body's principal chemical component. The average adult is made up of about 65% bodily fluid. And you are that way because pretty much all of your body's major systems depend on water to function. Water regulates your body temperature and dissolves minerals and nutrients and helps carry oxygen to your cells. Your body is what chemists call an aqueous solution. All of the chemical reactions that happen inside of you that make you you happen in water. But still, exactly how much you need depends on who you are and what you're up to. Your age and weight and diet and level of activity, even what kind of climate you live in, all affect your hydration requirements. If you're running marathons in August, for example, you're obviously gonna need a lot more water than if you're reading on the couch all day. But okay, you're looking for a number. I get that. You've probably heard a lot of them, so you're asking Google. And the guideline you've probably heard is that you should drink 8 8-ounce glasses or about 1.9 liters of water per day. And no one is really sure where that advice came from, even though everyone, up to and including doctors, has repeated it. But according to the Institute of Medicine, the average woman should consume 2.7 liters, that's 91 ounces of water a day, and men 3.7 liters, or 125 ounces a day. Now they point out that you actually get about 20% of your daily water intake from the food that you eat. More than that if you're eating a lot of fruit and vegetables. But still, the so-called 8x8 approach might not be enough to supply the other 80%. In the end, it's best to use your common sense and to listen to your body. It's a good idea to keep an eye on your pee. You want it to be a light yellow color, but really, just drink when you're thirsty and don't overthink it.
It might just be that easy. Thanks, Hank. Now, people asked about more than just fluid intake. They wanted to know how many calories they should eat in a day. Maybe the question's inspired by the references to a 2,000 calorie diet that you see on food packaging. Unfortunately, there's not an exact number we can give you, but we can tell you a thing or two about how to think about it for yourself.
Today's question: how many calories should I have in a day? You're probably asking because you want to know how many is too many. After all, you know that if you take in more energy than you need, your body will store that excess energy as fat. But before we can talk about how many calories you need, let's start with what a calorie is. The calories that you find on food labels aren't the same as what scientists call calories. In chemistry, a calorie is the amount of energy it takes to raise the temperature of 1 gram of water by 1 degree Celsius. But the calories listed on your can of soda are actually kilocalories, each one equal to 1,000 of the small calories that chemists use to measure energy. So when your soda pop says that it has 150 food calories, you'll notice it's written with a capital C. That's the same as 150,000 small calories with a little c. So that's enough energy to raise the temperature of a whole liter of water by 150 degrees. Kinda puts things in perspective. But how many calories you need depends on who you are and how you live your life. First, there's your age to consider. Despite the stereotype of the ravenous teenager, your calorie demands actually peak when you're in your mid-20s. That's when your metabolism is higher than at any other point in your life, and because you keep growing into your early 20s, once you're done, you have more lean muscle mass, which requires more energy to maintain. So depending on your lifestyle and other factors, when you're in your 20s, you may need from 2,200 to 3,000 calories a day. Your sex is a factor too. Men tend to have more total body mass and more muscle mass than women on average, so their caloric requirements can be slightly higher. According to the US Institute of Medicine, the average calorie range for the adult woman is 1,800 to 2,400 calories a day. For men, it could be anywhere from 2,000 to 3,000. But that's obviously a pretty broad range, and as delicious as it sounds, most of us don't need to be eating 3,000 calories a day. And that's because the most important factor, by far, that affects your calorie needs is your activity level. For example, if you're a woman in your 30s or 40s and you live a rather sedentary lifestyle, meaning you don't set aside time for exercise, then you probably don't need any more than 1,800 calories on average. But if you regularly take a nice brisk walk, say between 2.5 and 5 kilometers a day, then your caloric needs go up about 10% to 2,000 calories. And if you regularly walk more than 5 kilometers, or burn the equivalent amount of energy doing some other exercise like running, then you're looking at another bump, up to 2,200 calories. But when it comes to calorie intake, medical professionals will tell you that the real goal is to focus on your energy balance. That's the balance of calories you take in compared to the calories you burn through physical activity. So naturally, if you burn more calories than you take in, you're going to have to use more of the energy that you have stored up as fat. And on the other hand, if you consume more than you use, you'll just keep building up those energy reserves around your midsection. Since no one burns the same exact number of calories that they eat every day, the key is to maintain energy balance over the long term. So, if you consistently ingest more energy than you use, you'll be out of balance, just as you would be if you keep burning more energy than you supply for your body. But, if you ask me, you look fantastic.
Oh, you always know just what to say. And finally, some of the questions people asked were really big ones, like the one it probably occurred to every single one of us to ask starting around age 4 or so. Why is the sky blue? Fortunately, that's an easy one for science to explain, although there are a surprising number of elements that go into it. Here's Caitlin to tell us more.
The sky is blue because of 3 things: light from the sun, particles in our atmosphere, and the fact that you're a human. I'll get to that last part in just a minute. But let's start with how sunlight interacts with particles in the sky. I'm not talking about dust or water droplets or other big particles which are sometimes mistakenly used to explain why the sky is blue. Instead, it's the very small particles in our atmosphere that make the sky look blue. I'm talking about molecules in the air itself, mostly molecular oxygen and nitrogen, O2 and N2. These molecules are super abundant in our atmosphere and so small that they're even smaller than wavelengths of visible light. And that's the key. Visible light consists of a range or spectrum of different wavelengths. Light with the longest wavelengths are at the red end of the spectrum, and light with the shortest wavelengths are at the blue and violet end. Since the blue wavelengths of light are shorter, they're more likely to strike those tiny molecules of oxygen and nitrogen more often. And when they do, they get scattered in all directions. This effect is known as Rayleigh scattering because it was first described by John William Strutt, aka the 3rd Baron Rayleigh, who in 1871 published his mathematical proof that blue wavelengths of light in the atmosphere are scattered 16 times more than red wavelengths. But violet light has the shortest wavelength of all visible light, and it's scattered even more strongly by tiny particles. So why isn't the sky purple? Well, this is where being human comes into play. Our human eyes perceive the middle of the spectrum most sharply, which is why blue is way easier to see than violet. So even though violet light is being scattered around like crazy, we just don't detect it as well as we detect the blue. And that's why the violet band of the rainbow is often the hardest for us to make out.
Well, now I feel like I'm missing out on a purple sky. But you guys had one more big question. What is love? Now, we couldn't really take on all the philosophical, social, and historical implications of that question, but we did explore some of its more scientific dimensions. We can at least make some attempts to study the biology and chemistry of love, and here's what that tells us.
Today's question: what is love? It's the kind of thing that keeps poets and philosophers up at night, but science actually has a pretty good explanation for it too. Actually, several explanations. And the answer might change depending on what kind of scientist you ask. A biologist would say it's all about reproduction and the evolution and survival of a species. A psychologist may go on about our need for togetherness and acceptance. But possibly the best way to understand love is through chemistry. Brain chemistry. Although the heart is our symbol of love for some reason, when it comes down to it, love is all about the brain. We know this because we can actually see love in action in brain scans. And you know what? It looks an awful lot like a brain on cocaine. As a person first falls in love, at least a dozen different brain parts light up to release powerful chemicals, hormones, and neurotransmitters that trigger feelings of excitement, euphoria, bonding, and butterflies. Research also shows the kind of unconditional love between a mother and child activates slightly different regions of the brain. Early romantic love and attraction, what you might call passion, is all about flooding the brain's reward systems in a tsunami of feel-good chemicals like adrenaline, norepinephrine, and dopamine. This is why a brain on intense new love looks a whole lot like a brain on coke. Adrenaline and norepinephrine amp up your heart rate and get you all restless, while those dopamine drips leave you feeling euphoric. These chemicals light up your brain's pleasure centers, lowering your pleasure thresholds and making it easier to feel good about everything. Interestingly, this kind of passionate new love is also marked by lowered serotonin levels, similar to those found in people with obsessive-compulsive disorders, which may help explain those 30 texts your infatuated new lover sent you while you were in the shower. Eventually, most of these more intense obsessive components of new love settle down into a deeper, calmer form of love associated with attachment and bonding. Here your brain chemistry starts changing again, and hormones like oxytocin and vasopressin take over. Their mission, like Al Green's, is to get you to stay together. You may have heard of oxytocin, the so-called cuddle hormone. It gets released during orgasms and for women during childbirth, and it helps cement bonds between people. And you can think of vasopressin as the monogamy hormone. And you know what's taught us more about it than anything else? Prairie voles, one of the very few mammals that mate for life. After mating, a male vole's brain gets flooded with vasopressin and essentially gets hooked on his mate forever. The two then have lots of sex, and all that tiny boot knocking keeps the vasopressin flowing. When researchers gave voles a compound that suppressed the effects of vasopressin, the pairs quickly fell apart, losing their devotion to each other. So while in the poetic sense, love may always be something of a mystery, from the scientific view, it is within the realm of comprehension.
Thanks for watching this compilation of Your Curiosity, which was supported by Brilliant.org. They're all about helping you to hone your scientific thinking skills and learn more about the world around you with courses about science, engineering, computer science, and math. And if you enjoyed the big questions we talked about in this episode, you might also like their course, Physics of the Everyday. From small stuff like how your toilet works to big stuff like how skyscrapers stay upright, this course covers the physics of the things around us. The courses are designed to be hands-on, with animations and quizzes to help guide your understanding the whole way through. And you don't even need an internet connection, since their iOS app now supports offline learning. Right now, the first 200 people to sign up at brilliant.org/SciShow will get 20% off an annual premium subscription. And by supporting them, you're also supporting us, so thanks for checking them out.